Hello viewers, you are welcome once again. We are still under logic, Christ Almighty God's algebra. Today we are going to treat law of constant. Law of constant. A law of constant, a number of constant by conjunctive statement, a law of constant by disjunctive statement. But we are going to first of all treat law of constant by conjunctive statement. Let us start. Law of constant. P and T is equal to P and F is equal to F. This is a typical example of law of constant by conjunctive statement. Why is it called law of constant by conjunctive statement? Is because of this and connective that combines P and F together as a compound statement. So, by the reason of this and connective that combines them together, it becomes conjunctive statement. That means this and connective that combines P and F as a compound statement that makes the statement to be conjunctive statement. So, since it is a conjunctive statement, he said that it's law of constant by conjunctive statement. Let's prove this statement. Proof. Suppose P and F is equal to F. We assume that the statement is true, that P and F is equal to F. That means contradiction. So we assume that the statement is true. And you see that whenever the left hand side equation is true, also the right hand side equation is also true. In the same vein, whenever the right hand side equation is false, also the left hand side equation is also false. He said that it is logical equivalent. It's logical equivalent. Now, since this equation is logical equivalent, we can transform it to biconditional statement, and it will still return logical equivalent. If and only if P and F, if and only if F. We have now transformed it to biconditional statement. And you see that whenever the left equivalent is true, also the right equivalent must also be true. Whenever the right equivalent is false, also the equivalent must also be false. But in this case, we don't have any possibility of truth here always for CT. So you see that they are equivalent. Whenever the left side of whenever the left equivalent is false, also right equivalent is also false. Whenever right equivalent is false, also left equivalent is also false. So it's logical equivalent. It's logical equivalent. And whenever I do this statement, there's no possibility of getting falsity, always truth. In this statement, this particular statement, whenever I evaluate it, the possibility of getting falsity, always truth. Because whenever P and F is false, F is false. Whenever F is false, P and F is also false. So always truth. We say that statement is tautology. This tautology. Being justified by logical equivalent. Being justified by logical equivalent. So if and only if and only if and only if P, now this statement is tautology. This expression is tautology. You can also transform it to a conditional statement and it will still return tautology. That is, P and F implies F. You find out that whenever the antecedent is true, also the consequence must also be true. So whenever I want to make this statement, the possibility of getting falsity always truth. So the statement is tautology. Is tautology. Being justified by logical implication. Logical implication. Being justified by logical implication. If and only if. Now, since this P and F implies F is tautology, this segment is tautology, we then deduce that P and F exist. P and F exist. In the sense that P and F is a proper implication of F. And if P and F, that is the antecedent, exist, it's after that it exists, we then say that P and F is logical implication of F. I mean the consequence. P and F is logical implication of F. So the implication of F. See, this is true that P and F is the implication of F. Also, this must also be true if and only if P and F is equal to P and F. That means logical implication is equal to itself. Logical implication is equal to itself. And it is true that logical implication is equal to itself and because it is logical equivalent. In the sense that whenever the left hand side of P and F is true, also the right hand side of P and F is also true. In the same vein, whenever the left hand side of whenever the right hand side of P and F is positive, also the right hand side of P and F is also positive. But in this case, we always have it to be false. I mean, the version of this statement, P and F is always to be false. So whenever the left hand side of P and F is false, also the right hand side of P and F is also false. Whenever the right hand side of P and F is false, also the left hand side of P and F is also false. We say it's logical equivalent. Being justified by identity. Being justified by identity. We continue. Say, if and only if P and F is equal to P and bracket, not P and P. You have seen that you have substituted this F with not P and P, because by law of complement, not P and P is equal to F. That's why we say that P and F is equal to P and bracket, not P and P. Being justified by, because this F is being substituted with not P and P, which is the equivalent of F, by law of complement. By law of complement. If and only if P and F is equal to P, I'm going to associate this. So let us interchange it to be P and P, the same thing, by commutativity, the same thing. So this P and bracket, P and not P, we are going to associate it. Associate P and P, all in brackets, and not P is still equivalent by associativity, by law of associativity. So you have bracket P and P and not P, being justified by law of associativity, by law of associativity. So if and only if P and F, P and F is equal to P and F is equal to P and not P. You have seen that this P and P have been substituted with P, because P and P is equal to P by law of idempotent. That's why you have substituted it. You substitute P and P with P, being justified by law of idempotent. By law of idempotent. If and only if P and F is equal to F, that means P and not P is equal to F. By law of complement, P and not P is equal to F. That's why I split P and not P with F. You justify by law of complement. You justify by law of complement. You have seen that you have now proved that P, our hypothesis, that means P and F is equal to F. You have now proved it. You then conclude, say, thus P and f is equal to f. We have now proved that p and f is equal to f. We are going to, since it is logical equivalent, it is law, it's logical equivalent, we are going to prove the converse. So by the principle of essentiality, we will establish that p and f is equal to f is law of complement by conjunctive statement. So let's prove the converse. Conversely, f is equal to p and f. This is the converse of p and f equal to f. You have seen that this p and f at the left side of the equation here has now become p and f at the right side of the equation here. Then f at the right side of the equation here has now become f at left side of the equation here. Now it's now converse. It's now converse. It's now converse of p and f equal to f. So we are going to prove that statement is also true. So suppose f is equal to p and f. And we know that this statement f equal to p and f is logical equivalent, because whenever the left hand side equation is true, also right hand side equation is also true. Whenever right hand side equation is false, also left hand side equation is also false. You say it's logical equivalent. But in this case, we don't have p in the valuation of this statement always f in both sides. So it's constant, always f constant. So whenever the left hand side equation is false, also right hand side equation is also false. Whenever right hand side equation is false, so right hand side equation is also false. You say it's logical equivalent. Since it's logical equivalent, we are going to transform it to biconditional statement. If and only if and only if and only if p and f. We have now transformed it to biconditional statement, in the sense that whenever the left equivalent is true, also right equivalent is also true. Whenever the left equivalent is false, also right equivalent is also false. Whenever right equivalent is false, also the left equivalent is also false. So whenever you want to validate the statement, that must be validating falsity, always truth. You say that statement is tautology. Is tautology being justified by logical equivalence. Being justified by logical equivalence. Now, since if and only if p and f is tautology, we can also transform it to conditional statement and it will still preserve tautology. That is, if and only if f implies p and f. Now you see that whenever the antecedent is true, also the consequence must also be true. But in this case, we have the consequence to be f and we have the antecedent to be f and consequence to be also f. So whenever f implies f is always truth. So in this statement, whenever we want to write it, you always have truth. In any case, it will give us truth. So we say that statement is tautology. Is tautology. Being justified by logical, being justified by logical implication. Being justified by logical implication. According to this side, if and only if. Now, since this F implies P and F tautology, we then deduce that it is certain that F exists. That means the antecedent exists because it's proper implication of the consequent. So if F exists, you say that F is logical implication of P and F, I mean the consequent. So F is logical implication of P and F. Since F is logical implication of P and F is true, also this also must also be true. That is, if and only if F is equal to F. That means F is equal to F is logical equivalent. So it is true that F is equal to F because whenever the latest of F is F, also the latest of F is also F. Whenever the latest of F is F, also the latest of F is also F. You say it's logical equivalent. Being justified by identity. That means the sameness. Being justified by identity. Say that if and only if F is equal to P and not P. P and not P. You see that this F here have been substituted with P and not P by law of complement. F is equal to P and P. That's why I substituted P and D. We substituted F with P and D, not P. Being justified by law of complement. If and only if F is equal to P and P and not P. You have seen that this P here I'm just going with P and P because P is equal to P and P by law of idempotent. That's what says P with P and P. Being justified by law of idempotent. If and only if F is equal to, now let us associate this P and not P. We have P and bracket P and not P by law of associativity. By law of associativity. It's being justified by law of associativity. It's still equivalent. By law of associativity. By law of associativity. If and only if F is equal to P and the F. F is equal to P and F. You see that this P and not P is equal to F by law of complement. By law of complement, this P and not P is equal to F. That was take P and the not P with F because they are logical equivalent. That's why you have F is equal to P and F being justified by law of complement. Being justified by law of complement. We go to this side. You see that they have not proved that, they have proved the converse, that F is equal to P and F. That means F is equal to P and the F. So they have proved the hypothesis. We then conclude, say, thus, F is equal to P and the F. Now, since I have proved the converse, by the principle of extensionality, we then establish that P and F is equal to F is law of constant. Is law of constant by conjunctive statement. Therefore, P and F is equal to F. So it is true that P and F is equal to F is law of constant by conjunctive statement. So at this juncture, we will draw a curtain. Thank you, viewers.